Alright, so we're going to go through part 2 of the test, and these were your 3 free response questions. I believe each one was worth 9 points, and there were 3 or 4 parts to each question. So starting off with the first question, it says, is f of x continuous at x equal to 1? So we're going to have to look at the limits from the left. Which would be using the left function, which is this guy. See, negative e to the 1 minus x plus 4. And then we'd also have to look at the limit from the right. And this is the right side. And the reason we're doing this is we first have to check if the limit exists. So looking at the left side, we would be looking at negative e to the 0, because I substitute in the 1, plus 4. That would be negative 1 plus 4. Therefore, the answer to the left limit is 3. The right limit, I'm substituting in 1, so that would be negative 1 plus 2 plus 2, and that also equals 3. And since they're equal, now we know that the limit as x goes to 1 of f of x is 3. And then the other piece of the definition we have to check f of 1, which is the actual y value. And this, because it has the equal sign, is what we use for the actual y value. Absolute value of 7 minus 1 is equal to the absolute value of 6, which is 6. They are not equal, therefore, not continuous at x equal to 1. Part B. Are any zeros guaranteed? So now that we're using the word guaranteed, that should help you realize we're using IVT. We're using the interval from 2 to 3. So if you're looking only at the interval from 2 to 3, that would be looking at this piece of the piecewise function. So you actually get to ignore the first and second pieces. So if we're doing IVT, first of all, we want to know that the function is continuous on the closed interval of 2 to 3. And we know that this is a cubic function, so the domain is all real numbers. There's no discontinuities. So I know that it's continuous on the closed interval from 2 to 3, which means it's also closed. So we got those two. So the third step is to actually find the y values. So f of 2 would be negative 8 plus 4 plus 2, which gives me negative 2. Let's hope I did that right. And then f of 3 would be negative 27 plus 6 plus 2, which gives me negative 19. Fourth step is check the y value that they're asking about. F of c would be 0. If you look here, 0 is not within the range. And the range we have is from negative 2 to negative 9, so IVT doesn't hold. And what that then tells us is that zeros are not guaranteed. It could potentially happen, but it's not guaranteed by the theorem. Letter C, find A, and I should have italicized that. Find A such that g of x is continuous at x equal to 1. So, for a piecewise function to be continuous, you would take the left piece, because that's the y value for the left side. We want the y value of the left and the y value of the right piece to actually be the same. And we want them to be the same at x equal to 1, so we're actually going to substitute in the 1. So we get 4a times 1 minus 7 is equal to negative 1 plus 4. And so we get 4a minus 7 is equal to 3. 4a is equal to 10, so a is equal to 5 halves. Number 2, find the average rate of change. So the average rate of change is the exact same thing as plain old slope. Not calculus slope, plain old y2 minus y1 over x2 minus x1, also known as f of b minus f of a all over b minus a. So the slope of this function would be well, let's come up here and find f of negative 1, just to make sure we have everything. That'd be 4 over 2, which is 2. Let's find f of 3, which would be 4 over negative 2, which is negative 2. So, we'll use this point as y2 and this one here would be y1. So I would do y2, which is negative 2, minus y1, which is 2, all over x2, which is 3, minus x1, which is negative 1. And so we get negative 4 over positive 4, and we get an average rate of change of negative 1. The instantaneous rate of change, this is the same as the derivative. So what they're asking us to find is f prime of 2. So we use the limit definition as h goes to 0 of f of x plus h minus f of x all over h, and the function we're using is 4 over 1 minus x. And remember, it does help to just write out f of x plus h, which would be 4 over 1 minus x plus h. And here's where most of you lost your negative, which created wrong answers. Remember, the negative needs to distribute to both. So we get 4 over 1 minus x minus h. So I'm going to distribute that now. Some of you have also figured out that when you want to find the slope at x equal to 2, you can use the 2 right away, meaning I could change that to a 2 and I could change that to a 2. That's fine with me also. Because that wasn't the way I showed it in class, most of you are still using x, so I'm going to do this answer key with an x. So f of x plus h is the 4 over 1 minus x minus h. F of x is 4 over 1 minus x, and then the whole thing over h. So first thing I'm going to do is get myself a common denominator. And I'm going to do that by multiplying this by 1 minus x and this by 1 minus x. Alright, and then this one by 1 minus x minus h over 1 minus x minus h. And things that have really been causing a lot of wrong answers, maybe you know that you're multiplying the whole thing, but when you guys are rewriting your answers, because you don't have parentheses around this, you don't distribute the 1 minus x, you actually only distribute the negative x, so that caused a lot of issues. So here I'm going to multiply my numerator right here, so that'd be 4 times 1 minus x. The middle piece right here, that minus sign, it's right here, and then I'm going to distribute this piece, 4 times 1 minus x minus h. The common denominator was 1 minus x times 1 minus x minus h, and if you remember me telling you, you do not need to multiply out your denominator. And then the last part here, and I'll do that in gray, is this big old divided by h. Instead of writing it as divided by h, we're going to multiply by the reciprocal instead, which is 1 over h. So let's multiply everything out, simplify as much as we can, and we get the limit as h goes to 0 of, right here is where I am, 4 minus 4x. This is negative 4 multiplied by 1, negative 4 times negative x, and then negative 4 times negative h. All over, and again, I'm not multiplying out my denominator, and then times 1 over h. So you'll notice that the 4 minus 4 will cancel, the negative 4x and the positive 4x will cancel. And remember, I did mention all the terms without an h have to cancel, because we have to be able to divide by this h and simplify it out. So we have 4h over 1 minus x, 1 minus x minus h, and then times h. So the h's cancel. We are left with the limit, as h goes to 0 of 4 over 1 minus x, 1 minus x minus h. And here's where I'm going to physically do the limit, which means this h is going to go towards 0. So my final answer becomes 4 over 1 minus x times 1 minus x. When you multiply two things, they become squared, which a lot of you put 2 times 1 minus x. It's 1 minus x whole thing squared. So that would be the derivative function, and then I need f prime at 2. So then I would do 4 over 1 minus 2 squared, so I get 4. Find the equation of the normal line. Well, at x equal to 2, well, I'm going to need f of 2, which is 4 over 1 minus 2, which gives me negative 4. I'm going to need f prime of 2, which we just found a second ago, and I believe that was 2. Let me double check. Oh, 4. So this was the answer for part B. But if I want the normal line equation, then we have to do y2 minus y1 is equal to m times x minus x1. And actually, I just realized you don't really need the 2 there. I like doing it without the 2. So this is the y value from the point. This is the slope, which is the same as the derivative. And then this guy here is the x value from either of the 2, because we're using the same x value. So what do we end up with? We end up with the equation of y minus y1, which is positive 4, is equal to. Now, if I was finding the equation of the tangent line, I would use a slope of 4, but because I'm using the slope of the normal line, I use negative 1/4, opposite reciprocal. So I get negative 1/4 times x minus the x value, which was 2, and you get to leave your answer that way. Alright, so if there are any horizontal tangents. So I see the word horizontal tangent. So in my mind I'm thinking we have horizontal tangents when the slope of the tangent line, which was 4 over 1 minus x squared, when the slope of the tangent line, so the derivative, is equal to 0. So I'm going to move the denominator to the right side by multiplying by it, and 0 multiplied by anything gives you 0. That's a false statement, so no. No horizontal tangents anywhere on the graph. There's absolutely none. If you don't believe me, here's essentially what the graph looks like. 1 minus x, so right now I'm actually graphing f of x, which is equal to 4 over 1 minus x, not f prime. So move to the right, and I'm actually going to rewrite it a little bit. Alright, so we move to the right, but then we flip it across the y-axis, so here. That would be the asymptote. No, it isn't. I'm going crazy. Sorry, guys. The asymptote is at 1, but let's try this again. F of x is equal to 4 over 1 minus x. There we go. Alright, so let's do it again. The asymptote is at positive 1, and that's because x equal to 1 gives me undefined. And then let's pick a number 10. You'll notice that it's negative. The graph looks pretty much like this. And the horizontal asymptote, because there's more powers on bottom, will be y equals 0, and that's this guy right here. So the graph does flatten out here and over here, but it always is either increasing or decreasing, so that you end up that the slope will actually never be 0. There's always going to be a slight, tiny little slant to the graph. Alright. Letter B says evaluate each of the limits. So, and I believe somehow I'm missing a question, it looks like. Oh, I remember why. I think it's hiding back there. Hold on one second, guys. Alright, sorry. I realized I was missing this question. So, what I asked for first was a sign chart for this function. The function is f of x equals blah, blah, blah. So, for a sign chart, you need your vertical asymptotes, and you need your x-intercepts. So, for this guy, I'm noticing that x equal to 4 is a removable discontinuity, so I don't actually need it on my sign chart. I can see that x equal negative 4 is a vertical asymptote because that factor in the denominator did not cancel, and the x-intercept you would find by setting the entire function equal to 0. And you can use the simplified function and not the function with the removable. That's this guy. Multiply by x plus 4 on both sides, and that would cancel, leaving you 0 is equal to negative x squared times 3x minus 2, so you have two zeros. This one would give you x equals 0. This one here would give you x equals 2/3. So my sign chart has, I believe, negative 4, 0, and 2/3. If by chance you ended up having 4 on there, it's not wrong. You don't have to have it though. So that's undefined. This is my vertical asymptote. I'll even write that down there. All right, so I'm going to substitute in a very large negative number. So when I do that, one thing I want you to realize is as I'm doing my sign chart, I'm using the most simplified version of the function, which means the removable discontinuity. I'm not even using it. All right, so if I pick negative 1 million, the beginning term, I'm going to call this whole thing the beginning term. Just so you understand, the squared happens first, then multiplied by the negative. What I mean by that is negative 1 million, if I substitute that in for x, when you square it, it becomes positive, and then afterwards you would multiply by the negative, which would make it still negative. Then this term, the second term, multiply 3 times negative 1 million, minus 2, that would still be negative, and the denominator would still be negative. Therefore, this is negative. Picking negative 2. Negative 2, the first term, this guy, would end up being negative. It actually is always negative. Negative 2 would cause this to be negative, but negative 2 would cause the denominator to be positive, so that's positive. Between 0 and 2/3, I would pick 1/3. This would still be negative, the first term. 1/3 would give me negative in the numerator, and in the denominator, 1/3 would give me a positive. So this is still positive. That's actually a result of this coming from negative x squared, because the squared power is why the signs didn't change. And then 2/3, pick 1 million. Positive 1 million would still make that first term negative. Positive 1 million would make the second term positive, and positive 1 million would make the denominator positive, and therefore this would be negative. So if you have 4 on your sign chart, you would just have 2 negatives back there. The value of 4 would also be undefined. All right, and evaluate each of the limits, and what I'm going to do is make this a little bit smaller and actually copy over my sign chart because I am going to need it. I'm also going to copy over the question in a moment. Let's try to get as much of this as possible without too much mess. Let's try that. All right, bear with me as I do this. Alright, so I want to give myself enough space to write. So I'll just stretch this out all funny. Make this a little smaller. So that's our sign chart. I'll put that there. And then I'm also going to go back and steal the function. And I'm going to steal the function with all the work I did to it, which means the dividing out of the removable discontinuity. And paste. Alright, so there's this guy. And just to be clear, I'm also going to simplify this all the way. So it would be negative x times 3x minus 2, just all over x plus 4. And then just remember, we know we have a removable discontinuity at x equal to 4. You'll notice right here, I ask about that. So I'm going to start with this guy. How do you know what the limit is for a removable discontinuity? Well, first of all, you know it's guaranteed that it exists because all removables look like that. There's a hole, but from the left and right, the limit will be the same. So all I do to find the value of the limit is substitute into the simplified version of the function. So negative x times 3x minus 2 all over x plus 4. And that gives me negative 4 times, I think 12 minus 2 is 10, all over 8. So I get, hopefully, negative 5. The y value that you received from substituting in gives you the actual location of your removable discontinuity. All right, let's look at 2/3, which was also on our sign chart right here. And hopefully, sorry, I cut this off a little bit. You can actually see that on the sign chart, It's on the sign chart because it's a 0. How do we know that? Because we solved for it before. Okay, so we're guaranteed if we're going to hit the value of 0, it's going to be a continuous value because we actually have the point exist on the curve. All right, these two are related. What you're going to do is any limit, negative, positive, infinity, you want to think about a horizontal asymptote, which we did not find in the beginning, but right here, those are your two highest power terms. And so what I'm going to do is do negative 3x to the 4th over x squared. That simplifies to negative 3x squared. I'm going to graph the end behavior, which is this guy. And now I know that if I do the limit as x goes to positive infinity, the answer would be negative infinity. If I go to x going to negative infinity, it's still negative infinity. So both of these answers are negative infinity. I'm going to show you one other way you could also do this. The end behavior model was negative 3x squared, and let's say you want to do the limit as x goes to negative infinity. What I watched people do on their tests, which was a great way to use, in a sense, substitution. When you get your end behavior model, substitute in your negative infinity, and you'll know, number one, the outside term is negative, but negative infinity times negative infinity makes it positive infinity, and that's how people figured out that this would still be negative infinity. That's another method to use. Really, the value that you get, that 3 won't do anything because we're multiplying 3 by infinity. It's still going to be a huge number. What really matters is based off of all the negatives that you have, will the whole term become negative or positive in the end? So a negative number squared gives you a positive. Negative 3 times would give you that negative, leaving us still with negative infinity. All right, last guy. X goes to negative 4 from the right-hand side. So negative 4 was the vertical asymptote. And if you look at the sign chart, and I'm going to highlight it with my highlighter here. Here's negative 4. If I'm coming in from the right side, that would be from this side here. And this pretty much tells you that, number one, this is a vertical asymptote. The only answers I can have are positive infinity or negative infinity. And I know by looking at the sign chart to the right has a positive sign to the right of the undefined at negative 4. And therefore, I'm guaranteed that my answer has to be positive infinity. And I did want some reasoning, so if you just put positive infinity but I couldn't tell why you got it, I did need to see why. Alright, last piece, write the piecewise function for f of x, which removes any removable discontinuities. So, how do we remove a discontinuity? Well, first, you start out with the exact same function that you started out with. And what I'm going to do is erase this guy, and then I'm going to copy just that part of the function over. Let's see if I can work this guy. Paste. There we go. So, what you'll notice is I purposely didn't write it. I wanted you to see I'm physically copying over the same exact function. And what you do is you put comma, and you let it be the exact function for every x value except for the removable discontinuity, which was at positive 4. What you then do is look for the location of the removable discontinuity. We found it when we were finding the limit, and that's what you put in for, not equal to, and you use the location for when it is 4. So going back, I just want to make sure, I'm hoping I found this value right. I don't know why, but I don't remember it being negative 5, but maybe it's just been a little while. I know why. Because this is supposed to be squared, and this is supposed to be squared, which would give me negative 16, 160, which will give me negative 20. And I'm guessing some of you probably are looking at your test saying, but that's not what I had, because it wasn't negative 5, it was negative 20. So, oops on my behalf. Let me go over and just make sure that I change it here too. So it was actually negative 20. And that should give us part C, which I think is the last part of the test. Yep. So going back over, that should give you all of the answers to the second part of the test. And hopefully that was enough help for you to figure out what you were doing wrong and what you were getting wrong and why. And remember, for your test corrections, I want them in a different color, and I want it to be very clear as to why you're getting these problems wrong and what you do to get them right. All right, good luck.